Okay, 5. What's one of the constructions it could be then? We only did 2 yesterday in your notes.
Like, I don't really know what construction means. What is construction?
Using your compass, right? Here's the first thing we did with it. What do we do here with it?
Oh,
What did we make?
what's it called?
What's this?
A line?
No, it doesn't have arrows.
Oh. Segment?
Okay, we got this is like vocab that's clutch on Friday, right?
Yeah.
This is a segment, and we copied it over here. So the first thing I could ask you on Friday is, where's my notes? Copy a line segment. What's the other thing? The last thing we did yesterday with this. Last thing we did. 6.
I don't know.
Last thing in your notes. No, there you go. Turn it. Turn the page. We'll get there. Where is it? Oh, actually, we did it earlier for you guys.
Find a midpoint.
Find a midpoint using compass and straight edge, right? This is all on Classroom as well, right? These notes you see up here are all on Classroom. Or will be anyway. All right, everybody good. So copy a line segment, find a point, find the midpoint. I'm going to ask one or the other. To me, that should be an easy 3-point question. Okay? Copy a line segment or find the midpoint using your compass or straight edge. Points, lines, and planes. Vocab. What's collinear? I'm not going to ask you to define it, but I'm going to ask for name 3 collinear points. And we got to know what collinear means to find 3 points. Anna?
All on the same line.
Points all on the same line. Coplanar. Points or lines in the same plane. Yep. And then how do I name a plane? Because I'm going to ask you to name a plane.
Uppercase letter in the corner.
Or if the uppercase letter in the corner is not there, how can I name it using points? Go ahead, Ona.
3 points.
But what about those 3 points? They got to be something specific. They can't be any 3 points. They have to not form a line. Okay, you name 3 points that don't form a line to name a plane. Good. Draw your own diagram given facts. That is, we did one problem like that, similar to that in your notes, way back in the day. Where is it? Page 5, number 4. Okay, page 5, number 4 in your notes. Okay, where I give you a list of requirements and you have to draw that diagram for me. Algebra with segments. What do I mean by that? I think we did quite a few of these in class and on homework. Real quick, I have a line segment. I just have a point in the middle that's not the midpoint. This is 2x plus, I'm totally making this up, so I don't know if it's going to work. 3x minus 6, and the whole thing is 5x plus 4. Find the value of x, plug it back in, find the value of each segment. Okay? So something like that. Algebra with segments. And then finally, there are at least half the quizzes midpoint and distance. So know our formulas, right? Know our formulas. Anything you want to ask more detail about, I'll be here today and tomorrow if you want to come in. But again, guys, we're not meeting tomorrow, so it makes me nervous. And we're not meeting tomorrow. No net I didn't put a net question on this one. I saved it for the unit test. So no net questions. Anything else? And this is up on Classroom too, under Unit 1, all the topics if you want to go back to it tomorrow. Last call, questions? We're all set? Okay, so I'm going to start moving on in the unit. What I'm doing today, not on the quiz, and the homework's due Monday, okay, because I'm giving you guys a couple nights to study. So this homework is Monday night, all right? Monday it's due. All right, Monday when we come back in, this homework's due. All right, ready to roll? Have that compass off to the side because we're going to use it eventually. All right, we're going to get away from segments and lines a little bit, and we're going to go to something else. First thing I want to introduce is some new vocabulary terms. Array. A line has what on it at the end? Two what? A line. What's it have at the end? Two arrows, right? What's a line segment have at the end? Endpoints. Now I'm going to kind of combine the two here. What about an endpoint on one side and an arrow on the other? That's called a ray. Okay, this is called a ray. So let's name that endpoint A. Put another point on here, B. All right, how do I represent this? Well, remember the symbol for a line? There's a small line, symbol for a segment, small segment, symbol for array, small array. But order matters now. Order matters. You could name it AB, line segment BA. The order never mattered. Now it does. You have to put the endpoint first. Have to. All right. So this is ray AB. You cannot call it ray BA. The endpoint must go first. All right. Come on. Okay. Endpoint. Got to go first. Okay. So there's a ray. Opposite rays. Yes. Two rays on the same line that share the same endpoint. So I need your help here. Can you guys name two opposite rays here? Two rays that share the same endpoint. Two rays that share the same endpoint up here. 11, what do you think? RS. RS is a segment though. Or RS and RT are the same rays. Okay. RS is still this ray. RT is still this ray. They got to go opposite, but share the same endpoint. Want to try again? Because you just gave me the same rays. RT. Okay. Do they have the same endpoint though? No, right? Start there. There you go. ST, SR. Everyone see they both share S and they're going in the opposite directions. Those are opposite. All good? Okay. That's great. Here's what I want to get into today though. When two rays meet now. When two rays meet, you get an angle. All right, this is something you guys have been used to. Ready? So I have one endpoint, one ray going the other one way, and one ray going another direction. There we go. We have an angle. Let's put some points on this angle right now. And let's put a number 2 inside of there. All right, how do I name an angle? 3 different ways. There's one way I'm going to prefer over all 3 of them, but 3 different ways to name an angle. One way is by the vertex. The vertex is where they meet. Okay, so what's the vertex of this angle? Where do the 2 rays meet? At E. So I could call this, here you go, ready? Symbol time. Angle E. Okay, angle E. Or sometimes I write it like this. Sometimes I put that little arc symbol through it. That also means angle. Okay, both of those mean an angle. Whatever you prefer. All right. Other way, I can name it with a lowercase letter or number inside the angle. So this could also be angle 2. Very rare though. That's a very rare one, but want to expose you. Here's what I prefer you do. Name it with 3 letters, where the middle letter is the vertex. Okay. Name the angle with 3 letters, where the middle letter is the vertex. So anybody want to angle? Have it. DEF. Yep. Angle FED. Fine. I prefer that. Here's why. Here's why I prefer that. Don't put this on your paper though. Let's say I make another ray. And you say, oh, this angle we've been talking about the whole time, angle E. I'm going to be like, angle E. Can you guys see multiple angle E's up there? So how do I know which one you're talking about, right? That's why I like this one right here. Name it with 3 letters, you can never go wrong. Because everyone see what I mean? If you name this angle E, I'm going to be like, what angle E are you talking about? So always be on the safe side. I would always do 3 letters. Good? All right, here we go. I think have you seen all 4 of these types of angles before? Okay, right angle, what do you know about it? Measures. What did you say? 90 degrees, yep. Measures 90 degrees. Now, quick question, especially in this level of math, you're not going to just see 90 degrees written in. Anybody know what you're going to see to show it's 90? I can start learning here. Rachel?
The little square.
The little box there, right? So this is what you'll see. You see that? I know that's 90 degrees. Straight angle. Anybody know how much a straight angle measures? Where you guys got?
It's like 180.
What's another name for a straight angle? A line. Yeah, that's all it is. Yep. Measures 180 degrees. It's a line. (180 degrees). Acute? Anybody ever hear acute? Rachel?
Less than that.
Okay, yep. I'm going to just change that slightly between 0 and 90. All right, because you can have negative degree angles. You guys will deal with that next year. So I'm going to put between 0 degrees and 90 degrees. And then obtuse?
Between 90 degrees and, well, between 90 degrees and 180 degrees.
There you go. Yes, you can have an angle bigger than 180. That's next year. So we're going to say between 90 and 180. Yep. All right. Just want you to be familiar with the 4. Questions from you guys? All right. Q. Congruent angles. Angles that have the same measure. All right, we're going to construct it in a second. Don't pick it up yet. I just want to show you some symbols again, some markings. So draw me angle ABC, please. ABC. And also an angle that looks kind of congruent to it, DEF. Okay, and please don't put this in. Unless I tell you like this is 50 degrees and this is 50, you guys are not going to know if they're congruent or not. And you're not going to assume they're congruent. We talked about that. Don't assume anything. So if I don't have the measure in there, what other markings could you see to say that they are congruent? Well, remember with the segments, what do we put on segments that say they're congruent? The hash marks, right? Well, I don't have hash marks for angles. Instead, I have, let me introduce you to, I have arc marks. I see this on two angles, that tells me they're congruent. Okay, if I see that on two angles. So let's write it too. Angle ABC, remember the congruent symbol? Congruent to angle DEF. Okay. So if you don't see actual degree measures in the angles, but you see the arc marks, good enough. They're congruent to each other. All right. All right, let's grab your straight edge and compass. I'm going to show you how to make a congruent, an angle congruent to another one. All right, everyone see angle A? I want to make it congruent, and we're going to make angle B out of it now, angle B. Okay, first step, draw a ray. Take your straight edge and draw a ray coming from B. Grab your compass. Put it on vertex A. Put it on vertex A of angle A. And what you're going to do right now is you're going to make an arc. Sorry. You're going to make an arc that goes through both rays right now. Okay, so put your compass on vertex A. Make an arc that goes through both rays. Keep that opening the same on your compass. Keep that opening the same. Travel over to point B now with that same opening. And make another arc going through your ray. Make another arc going through your ray. Okay, go back to angle A, the one we're copying. Do you see when you made the arc, you made 2 points of intersection on the rays? Everyone see mine here? I made 2 points of intersection. Put your compass on those 2 points now and open it up to that length. So you had 2 points of intersection that you made. Open up your compass to those 2 points. Open up you shouldn't have it on the vertex. We shouldn't have it on the vertex. Open it up to the 2 points. Let's go. Okay, go back to your one you're constructing now. Here you go. I know what some of you guys you're trying to get ahead of me. You're trying to put it on, no. You don't put it on B. You put it on where the arc intersected the ray. Okay, so put your compass point right now on where your arc intersected the ray. And you can do this above or below, it doesn't matter. But now you need to make an arc that intersected your first one. Okay, from that point of intersection. You can do this above or below, doesn't matter. And when you're ready, grab your straight edge, draw in your other ray to make angle B. How can you show these two are congruent? What did we just show? What can I put on them now? Arc marks, yep. I like to do double so it doesn't look like it's a construction mark. There you go. Those are congruent. All right, I want you to practice now. Somewhere on that page, you got plenty of white spaces. I'm looking around. Okay, draw your own angle. Just freehand it right now. Draw your own angle. Start yourself off with a ray and see if you can copy. See if you can copy that angle. I know the steps it's a lot to remember. Measure the distance between the points of intersection and then go over. Don't put it on your end point of your ray, put it on your point of intersection. Everyone doing all right? Your third construction. Before I move on, because I haven't. We're still going to do another construction before we leave today. I understand. I'm with you guys that I'm doing these constructions and the steps are hard to remember, right? I'm in agreement with you. The steps are hard to remember. So here's what I have for you. If you're ever doing these on your own and you forget, oh, geez, what was the first or second step in copying an angle? Please go to Classroom. Right under Unit 1, I have a topic that says construction help. And what it is all the videos of, or it should be, there we go. Videos of every single construction we're going to do through the entire year. Okay? All the constructions. So let's say you forgot to do, copy an angle. You scan through, and yes, I know this is intimidating. Look, copy an angle. And then you go through the ads because we're that popular. Yep. And there it is. Okay, you can just follow right along. Those are all the steps we just talked about. Boom, boom. All right, all good. So we have this resource on Classroom for you. All right, and this is not just one we found on the internet. This is myself and Mrs. Linehan, who's the other honors geometry teacher. All right, so this is us how we teach it in class. Okay, so that's there for you guys if you ever forget. So what am I trying to tell you? No excuses. Right, no excuses. All right, let's get moving back here. Copy an angle, we're all good. All right, last vocabulary term. Angle bisector. Bisector. Bisects. Cuts it in half. Okay, cuts an angle into two congruent parts. Cuts an angle into two congruent parts. Am I going to have you construct? Okay, so we are. All right, so before given angle AX bisects, angle BAC, conclude. Okay, yep. All right, so first, up on top, just draw yourself angle BAC right now on top. Draw your, we're going to do a construction on the one I gave you. So right now, just draw me angle BAC, please, BAC. And then I'll show you how to construct this. Okay, ready? Go ahead and draw in ray AX. That bisects it, cuts it in half. Ray AX. Cuts it in half. All right, I'm stopping. I'm stopping here because this is where you guys got to take over now in this class. What can you tell me is true? What markings can you put on the diagram? AX bisects BAC. Again, bisector cuts the angle into two congruent parts, cuts the angle in half. What can you tell me is true right now? What conclusions can we write up here? Give me a true fact if you know that's an angle bisector. Start naming some stuff up here. AX cuts it into two congruent angles. Let's go, Abbott.
Angle BAX is congruent to angle XAC.
Angle BAX congruent to angle XAC. Good. Everyone agree? Cuts it into. And now what can I put on the diagram? That's also true. What can I put on my diagram to show this? I got to start going here. 5. What can I put on my diagram?
Two congruent symbols, just like the
Arc marks, right? And also just try to offset them a little bit because when you just do them right next to each other, it kind of looks like you're talking about the whole angle. So try to offset them. Okay, there you go. Angle bisector cuts it in half. These two are the same degree measures. All right. All right, ready to construct it now. Ready to construct it? All right, grab your straight edge and compass. Let's do this. We're going to bisect BAC, so there's no reason to make a new angle. We're going to do it right on the angle they gave me. Take your compass, put your vertex on A, or put your compass on vertex A. Make an arc, again, going through both rays. Make an arc going through both rays. You just made 2 points of intersection, right? You just made 2 points of intersection again. Okay, put your compass point on one of those points of intersection. Make an arc, not a big one. Make an arc mark above your first one. And you can keep your compass opening the same this entire time. So get it above. Go to the other end point. Go to the other end point. And make another arc mark so your last two intersect each other. These two intersect, the ones above. So it almost looks like a little fireworks going on. So I made the first arc mark, put my compass point on one of the points of intersection, made an arc. Put my compass on the other point of intersection, made another arc so they intersected. And then grab your straight edge. Line it up with the vertex. And draw in it's asking for what? A ray. Draw in a ray that bisects that angle. And put something on your diagram that shows me it bisects. Put something on your diagram. Questions before we go some algebra to end class? Using this new term bisects. We're all good? All right, let's do it. Read the directions first because it'll give you some important info. Kn, everyone see ray Kn? Everyone see ray Kn on the diagram? It bisects LKN. I want you to mark what two angles should be congruent then. If Kn, ray Kn bisects LKN. Follow the order of the letters. Follow the orders of, so you know where the angle is. LKM, this angle right here, Kn bisects it. So which two angles up here should be congruent? Which two angles? LKN is getting bisected. Which two angles should be congruent?
MKN,
And?
MKL.
Good. Mark it now. Mark it. Mark it. MKN, NKL. They're congruent. All right, let's fill in let's do example 1 now. LKM, LKM. Everyone see it? Follow it. I always trace it with my finger if I have to. LKM. This whole thing here is 7x minus 5, the whole angle. 7x minus 5. Measure of NKM. NKM, 3x plus 9. What is the measure of LKM? In degrees. I don't want, don't give me 7x minus 5 again. In degrees. So we need to set up an equation here to try to solve for x. I'll let you ponder this a little bit. We put those symbols on for a reason. How am I going to set up an equation so I can solve for x? Because once I know x, I think I can get rolling. I like it. I like it. Let's talk to somebody here. 6. Who's got 6? All right, ready?
Yeah.
Think you got something, or
Yeah.
go ahead.
3x plus 9 plus 3x plus 9 equals 7x minus 5.
Awesome. Hey, if that's 3x plus 9 and these are congruent, doesn't that one have to be 3x plus 9 as well? Awesome. Yes. So 3x plus 9 plus 3x plus 9 gives me the whole thing, 7x minus 5. Yes. Let's go. Here we go. Combine your like terms. 6x plus 18 equals 7x minus 5. Move everything over. How about 23 for x? 23? Is that my final answer, though? See, this is a problem I always get every year. Kids get so happy when they find the variable, but they forget that's not what we were looking for. It helps me get what we're looking for, but it's not my final answer. Plug it back into LKM now. So 7 times 23 minus 5 will be my answer. When you have it, let me know. 13.
156.
156. Look good. 156. Bonus question. What type of angle is that then? Obtuse. Yes, great job. Obtuse. All right, we're going to do example 2 and we'll call it a day. All right, same diagram. Hey, same directions. It still bisects, okay? I just have new values in here now, or values in different spots. So still congruent. Still bisect, so these two are still congruent. Come on. These two are still congruent. All right, now let's label them. NKL, everyone, NKL. 7x minus 9. JKM. Everyone find that one. Trace it with your finger if you have to. JKM. X plus 3. Find JKN. Ooh, wow, this is a tougher one. JKN, this bigger one. Yeah. All right, let's talk. You got to set something up to solve for x, right? Are these two I labeled congruent? X plus 3, are these two angles congruent? No, no idea if they are or not. No idea. I don't have arc marks there. Okay, so I just can't set those equal to each other. Well, let me help you on your way. What's MK? What can I label MKN as? What can I label MKN as? To help me out in this diagram. 13 again, MKN.
7x minus 9.
They're congruent, yeah. So let's put 7x minus 9 there. I don't know if anybody sees it yet. I don't want to set, hey, I don't want to do this, right? 7x minus 9 equals 7x minus 9. We're not going to get too far there. If I combine all 3 of these angles, doesn't it form JKL? Everyone agrees if I take all 3 and combine them, I get this one right here, JKL. And what do you know about that?
It's 180 degrees.
It's a straight angle. Everyone see that? It's a straight angle. So I can say 7x minus 9 plus 7x minus 9 plus x plus 3 equals 180. Yep, all 3 angles form a straight line. Great. And let's finish this up, huh? How many x's do I have there? 15? What about my numbers? Minus 15? $13? X is 13? All right, but remember, we're looking for JKN, right? So not only do I have to plug x into x plus 3, but I also have to plug it into 7x minus 9. Everyone see that? To get JKN. So I got to go 13 plus 3. And then I also have to plug it into 7x minus 9. And what are we getting for this angle? 7.
98 degrees.
98. How's that sound, everyone? What type of angle is this? Obtuse. Yeah, above 90. Yeah, it's not a right angle. All right, so that homework. I know we need to get to the other problem. We'll get to that on Monday, but this homework's due on Monday. Okay, this homework is due on Monday. I'll remind you tomorrow and Friday. Quiz on Friday. All right, there's no reviewing when you get in, no asking questions. Make sure your compass and straight edge is here with you. I'll still see you guys tomorrow for homeroom, but then we'll be going to the auditorium. After school both days, today, tomorrow, if you